Here we go. Let's solve this quadratic equation. So step number 1, let's find the critical values. Step 2, let's plot on a number line. Do you think I'm crazy here talking to myself?
Yes.
Plot on a number line. And 3, test for inequality, however that's spelled. All right, so getting the critical values means I'm solving this quadratic equation. Here we go. So let's solve that. PSF this ugly thing. That'd be 5 times 8. That'd be negative 40y squared. The middle term's got to be 6y. So that means the factors of 40 that will add up to 6 would be 10 and 4. So it'd have to be positive 10y and negative 6. Sorry, negative 4. Those will add up to 6y. So I'll rewrite this as 5y squared plus 6y minus 8 equals 0. I'm going to rewrite that as this, plus 10y minus 4y minus 8 equals 0. Factor that in pairs, and that would factor to y plus 2. Factor out the negative 4, and that'll be y plus 2 equals 0. So that means my nice pretty factor is this. That's my factor form, which means my critical values are y equals 4/5 and negative 2. Right, so I've got my critical values. Let's plot these on a number line. All right, so I've got negative 2 way over here. 4/5 will be way the heck over there. All right, that creates 3 regions. 3 regions. We're going to find these regions where the inequality exists. So let's pick a number bigger than negative 2. So using the calculator, I'm going to pick a number less than negative 2, stick it in this thing, and see if it's greater than 8. So let's do negative 3. So 5 times negative 3. Notice I'm putting the negative 3 into the brackets. Squared. And plus 6 times negative 3. Now what I care about is this greater than or equal to 8. Is that greater than or equal to 8? Well, yes, indeed it is. So I know I include negative 2 because I've got the equality bar there. So it appears that everything to the left of negative 2 would be part of this solution. All right, so let's check in between here. Let's pick a number between negative 2 and positive 4/5. We'll just say pick negative 1. So I'm going to pick negative 1 in there and see if that is part of the equation. So 5 times negative 1 squared plus 6 times negative 1. That is not greater than or equal to 8. So I know we're excluding in between. More than likely is we are going to include everything to the right of 4, but I'm just going to test it to show that indeed it is. So let's pick a number greater than 4/5. How about 1? Let's do 1. So then that would be 5 times 1 plus 6 times 1. Is that greater than or equal to 6? Yes, it is. So here I've graphed the solution. Let's interpret this into our actual answer. If that is the case, that means that y is greater than or equal to 4/5, but less than or equal to negative 2. And that would be the solution to this inequation.